And it is now our pleasure to welcome Jack Schmitt to give us his response to the continuing discussion of transformational lunar science. This is a 30-minute talk. I'll give you a 2-minute warning.
Okay, thank you. Well, thank you very much. It's a great pleasure once again to be with you. We had a great time last year, and we're having a great time this year. I'm just going to initially talk of some personal reminders for you related to the discussion presented to us by the panel. Very, very intriguing discussion indeed. But I just want to remind you that the giant impact model has not been confirmed, as was also mentioned earlier. And the difficulties are primarily in explaining the field data, isotopic ratios, and pyroclastic volatiles. I, of course, through the years have been a skeptic on a lot of things, particularly things that have to do with models. And I just would suggest that we keep in mind what potential alternatives to giant impact might exist, such as capture. The planet migration model is not confirmed, although I find it very intriguing. And as Dave pointed out, we really have insufficient age data on large basins. And when we say age data, I mean precise age data. In my estimation, we still don't know the age of Imbrium. We know a range of ages, but having a precise age of Imbrium, I think, is still beyond our activity right now. And we'll talk a little bit more about the importance of vastly improving our ability to do isotopic age dating. And in the transformative paper, science paper, it mentioned that Imbrium dominates samples that we have returned to the moon. That's certainly not true for Apollo 17. We have 3 or more basin-forming events represented. And again, though, we need to try to get much more precise age data. Some more reminders. Sample of the lunar mantle appear to be in the Apollo 17 suite. Textures and iron isotopes has been presented previously at LPSC in 72415. The dunite and also 76535, a troctolite, are indicative of having come from deep within the interior of the moon, certainly deep within the upper mantle of the moon. And by the way, I distinguish upper and lower mantle, and that has not been done, and I think it's very important to consider that distinction as we talk about these things. Now, I would strongly suggest that we have a mission of the Apollo collection, the entire collection, to find more of these potential mantle samples. And again, remember, there are 2 collections. There's one that we generally access through LESAP, and then there's the other that now I'm beginning to wonder whether I was right when I was in the Senate to keep encouraging that we separate the samples for protection. But we need to now that we think we're going back to the moon, let's start looking at all the samples. And let's look at the whole rocks rather than just little tiny aliquots. And those of you who have influence over LESAP certainly need to push that concept. I know Dave agrees in that, and I hope everybody else does as well. Now, we also have indirect samples in the melts derived from the upper mantle. That include the basalt and the basalts and the MG suite, so far as we know right now, as well as the volatiles in the pyroclastics, both the orange and the green glasses. Those volatiles probably come from the lower mantle of the moon because they're totally unrepresented in the basalts that we have sampled. And also, there's some talk about electrostatic dust, movement of dust, and I just would suggest with the background rock that you see there, which was about 7 kilometers away from the lunar module, it is clean. There is not dust accumulating on in the various surfaces of that rock. Dust movement is something that I think you need to take another hard look at it. There are transformative managerial, infrastructure, and operational steps required in order to reach some of the goals that have been presented this morning. There's particularly a geopolitical focus is required, and Ben, I'm sorry, I didn't hear that in your presentation. I hear the gateway doesn't seem to me, and it hasn't been convinced, I have not been convinced, provides the kind of geopolitical focus that I think the President and the Vice President have in mind for this new initiative. The management environment of NASA does not resemble that of the Apollo program, where focus existed, single-minded focus existed. We need to try to find a way to get back to that kind of focus if we're going to implement the President's initiative. NASA has to get back to find a way, and Congress needs to provide a way for them to stay young. The average age of the engineers and skilled workers in NASA during Apollo was in their 20s. You need that kind of stamina and imagination and everything else that goes with being in your 20s. And the management reserves that we had in Apollo, believe it or not, were 100%. I don't think you need 100% management reserves now to accomplish that, this new Moon-Mars initiative. Because we know a lot more than we did before Apollo, but management reserves are absolutely essential if you're going to make your milestones, stay on schedule, and keep political support. Those of you who can influence OMB and the Congress need to make that very, very clear. I happened to be in the Senate when we were trying to make first launch of the shuttle spacecraft. We weren't going to make it because there were no reserves. The milestones kept getting slipped in order to deal with the unknown unknowns that always come up. And if Hans Mark had not convinced the president then, Jimmy Carter, that you could not verify the SALT II treaty without the space shuttle, we would not have gotten to first launch on the space shuttle. So that's how critical having those reserves is in order to maintain schedule. The transformative infrastructure is very, very important. We have now the SLS being built. That is certainly a Saturn V plus launch capability in the long term. At least they have indicated to me that they have the ultimate capability to get to about 100 metric tons on a lunar trajectory. We'll see if that's possible, but that's what I think it's going to take in order to really make the moon a part of our economic sphere. Fusion or fission space power, that's electrical power at the surface, I think is going to be absolutely essential and is certainly transformative. Fusion interplanetary propulsion will be very transformative. And let me remind you that the initiative is a Moon-Mars initiative. And what Ben described was not a Moon-Mars initiative. It was a moon-centric initiative, and not even one, as Carly pointed out, that is totally moon-oriented. So if you want to go to Mars, you almost certainly are going to need an interplanetary propulsion system, probably a fusion system that shortens that transit time. Whatever we learn, that's going to be very important. Lunar settlement for resource production, I think, is absolutely critical. And I would just remind you that these resources are available anywhere. You don't have to go to the poles. It just depends on how you produce them. The solar wind volatiles and the fertility of the lunar soil is available to you wherever you are on the moon. So you just have to optimize where is that you want to do the trade study to see what's most economical. It might be the poles, but you can produce these kind of resources anywhere on the moon just by heating the regolith and then refining the volatiles that come off. There are transformative operations required. As was mentioned earlier, crew scientific field experience is absolutely essential, and it's more than just training a crew. It's having professionals on board those crews who can apply their experience to the new situations that are encountered. The pilots that we had in the Apollo days did an outstanding job in assimilating the training we gave them, but you can't assimilate experience that a professional has during that very short training cycle of, at the most, 15 months. We need confirmation of 1/6 gravity readaptation. My impression was that I was readapting to a gravity field. That's an impression. We need to verify that because it has tremendous engineering consequences if you are not adapting or if you are to the Mars mission. 3/8 gravity on Mars is either going to be a detriment or a readaptation assist, and we just don't know that. So very early on, we need to have that information. And by the way, Gateway's not going to get us that information. That's very important to get. The ISS is going to be an important part of this. I think it is possible to commercialize privatize the U.S. Portion of the ISS and its responsibilities, but we still need to have a systematic, scientifically grounded program of understanding space adaptation syndrome. We have not done that. It's been argued that we should have for the last 45 years, but it's not happened. We have some incidental information, and some of it very important. Skylab, by the way, was the only really strong, scientifically grounded biomedical program that we've had. And we need to get much more information about that if we're going to expose human beings to a deep space environment for long periods of time, including indefinite periods of time. I'll talk more tomorrow about spacesuit design, so I won't use time on that right now, but a clean slate spacesuit design effort, I think, is absolutely essential. Upper atmosphere verification of Martian entry, descent, and landing is also essential. We don't know how to land atmosphere environment of Earth orbit. Autonomous Martian operations, we don't know how to conduct those yet. Just because of the time delay, it's going to be very, very different. Landing, and that's why I have been advocating that we change our engineering thinking as well as our operational thinking to all aborts being aborts to land, not aborts to come home. Can you imagine spending all the money, going to Mars, all the effort, all the time, and aborting to come home? I don't think so. So I think we need to relook at all of that. It would be indeed transformative. Lunar verification of Martian systems and operations, it's an ideal place, only 3 days away to do that. Analytical systems for in situ exploration are going to be extremely important, both on our return to the moon and also on Mars. Now, transformative science, we've said it before and we'll keep saying it, accurate, precise, tightly targeted isotopic studies. We just have to be able to do that, both in terms of isotopic ratios, and we have done a lot on that as the data on oxygen isotopes just presented earlier have shown, but age dating, precise age dating is going to be extremely important. I would suggest that Apollo 18, since we never flew it, now be targeted to the existing sample collections. There are 2 of them, I'll remind you again, to better inform future exploration planning. Mobile analytical robotic systems to pyroclastics can further refine our understanding of these lower mantle signatures. By the way, I think that lower mantle is much more chondritic, remained relatively cool throughout lunar history, and has a great deal to tell us. The first ability to get to that is through these pyroclastic volatiles. The mobile analytical robotic missions to small craters in Cayley, this is just a personal interest to me because we have that little gap in our lunar history of what happened just before the Mare began to erupt in any particular region. And we've all talked about that before. I think we're beginning in the Apollo 17 regolith samples to see what that lithoclastic eruptive period might have been. Now, transformative commercial, there are two things that I would strongly recommend that we look at, and that is the 23 MeV gamma ray detector in lunar orbit. That detects the concentrations of helium-3 on the surface due to helium-3 neutron capture, producing that particular gamma ray energy particle, and the distribution. And as a consequence, we get the distribution of solar wind volatiles. Now, there are plenty of other sources of volatiles, as Carly has pointed out so well, but at least we would understand the distribution of solar wind volatiles if we understand the distribution of helium-3. Lunar settlement and resource production, I think, can be a commercial operation, particularly if it turns out that lunar helium-3 power production here on Earth is feasible. That is a tremendous opportunity for commercial activity. And with that, I'd be happy to take any questions that you might have.
Thank you for that provocative talk and your insights. You've been a hero to many of us for many years. I know there are going to be questions for you. And here's Ben now.
Your hero. So the one thing you said that I'm going to push back on is about the Mars side. I won't argue with you about whether the gateway is the optimal way for getting to the lunar surface. I do think there are geopolitical benefits. We have our other agency partners very interested in working with us on the gateway, and they very much want to get to the lunar surface too. But the one thing I do disagree with you on is you saying it not being Mars forward. If you remember, when the gateway was first proposed, it was in the same orbit. We were going to send the deep space transport for Mars to the gateway. We were going to do the life science experiments that we need to do on gateway to help us get to Mars. I agree with you that I think we need propulsion systems that let us get there quickly. That is going to solve a lot of the problems. But the idea of the deep space transport going from the gateway to Mars hasn't changed. It's just been pushed to the right because of the funding and the focus, the important focus of getting to the lunar surface.
Well, I appreciate that, Ben, and we can agree to disagree. I just think that effort and resources should be put into a human lander, and because that's much more Mars forward than the gateway, in my opinion. There's so many things we have to understand about working on Mars and getting to Mars that I think it's critical to establish ourselves essentially permanently on the lunar surface. And the gateway just seems to me to get in the way. I'm sorry.
Okay, Jim. I wanted to get back to the far side of the moon. I've heard a lot of interest in that, and I wanted to hear your perspective on human exploration to the far side, and if that would be challenging in other ways or feasible in your mind.
Well, for the moon, working on the far side without communications would be a little bit like working on Mars. I mean, it would be autonomous. So you can simulate that. Now, I don't advocate that. As was mentioned earlier, I tried to get NASA to consider a landing in Tsiolkovsky for Apollo 17 because we had the photographic coverage necessary to do that. And and we also had identified, my little Lunar Mafia team had identified, got in trouble for doing it, but nevertheless identified 2 Tyro satellites that could have been placed in the libration point behind the moon to provide continuous communications. So that was feasible technically in the Apollo era. It certainly is feasible now. Again, I would strongly suggest putting those communication satellites in behind the moon in order to land there. I would not pick Tsiolkovsky at this time. I think South Pole Aiken is clearly a much more interesting target. If I could figure out a way to identify the precise age of Procalarum, I would suggest that we ought to also concentrate on that. I may be still the only person besides Don Wilhelms that thinks Procalarum is a impact basin larger than South Pole Aiken, and probably triggered that magmatic event that was mentioned earlier, rather than South Pole Aiken. But that's a debate we can have over a beer or two. Carly?
I was surprised in your presentation that you didn't say more about getting boots on the ground, but I was happy to hear your response to Ben to really focus in on that. One of the points that you made in one of your view graphs was something about revalidating the 1,6G readaptation, which presumably is people on the surface of the moon, but I wasn't quite sure just what you were talking about for that particular aspect, because it seems to me that there's this unique environment that when people are on the moon. Could you expand that concept a little?
Yes, it just that you would integrate into your operational planning those things necessary to understand whether readaptation was occurring. The medical tests, I don't think it has to be just standing there and waiting to readapt. I mean, you put it into your whole operational planning to find out just whether that adaptation at 1/6 gravity is indeed occurring, as I think it was. But it's just something you have to do. It's a space biomedical research project. It needs to be done well scientifically. The one thing that has not been done with the space station nearly as much as it should is the pre- and post-flight characterization of the physiological baselines of astronauts that have been exposed. Now, in the twin study with the Kellys, to a significant degree, that has been done. But we need a much larger N than just the Kellys. That's what's missing, is that N to understand the individual variability. In the early days, we talked a lot about bone demineralization, for example. Well, not all individuals have shown bone demineralization. Now, fortunately, I think the new exercise machine on the ISS is showing that we can solve that through exercise. 2 hours a day is my understanding, but still you can deal a lot with bone demineralization and muscle atrophy with the proper kind of stress exercise. But there are many other things that we don't understand scientifically about these adaptation processes, and the ISS has so far been wasted to a large extent in getting that kind of information. Let's don't waste our return to the moon. Boots on the ground, yes, I think that's absolutely essential, not only scientifically but geopolitically, because somebody else is going to put their boots on the ground if we keep treading water on building a broad-based infrastructure. I think we need to do that, and there are a lot of advantages scientifically to doing that, as well as advantages to understanding the operational issues that are going to face us on Mars.
Okay, one more question from Jen Hilton.
Hi, Jen Hellman, NASA Ames. So there were dozens of robotic precursors prior to Apollo, so I hear. So I'm wondering if you feel that there are any precursor measurements that need to happen or information we need to know before we send humans back to the moon to do some of this advanced work that you're talking about, or if we're good to go.
I would say no. I think LRO and LROC and the narrow angle camera and also the mini RF have pretty well given us the kind of information we need to plan. Like GRAIL has given us a model now of the gravity field of the moon, which we can integrate into our flight planning. I think we're in good shape for returning to the moon, absolutely good shape. In fact, we're in better shape for going to Mars now from the robotic missions than we were before Apollo. Apollo had lunar orbiter to give us landing site information. We had Surveyor, Ranger and Surveyor, but mainly Surveyor to tell us that we could indeed land on the moon. But that's about what we had. Now, I mean, just look at what, and you'll hear more about from Noah, about LRO and LROC. We're ready. From that data point of view with LRO and GRAIL, I'd say we're more than ready to get back to the moon and basically land anywhere we want to. Now, you have to evaluate the orbital mechanics of each landing site and then the trade-offs, scientific as well as operational. But the main focus, I think, should be to get on the ground, pick those sites, get on the ground, and start to understand both the science of that site and begin to understand how we're going to operate various kinds of systems on Mars. The fortunate thing about the regolith is that about 1% of the regolith is less than 1 micron in diameter, and that should be a good test of a whole bunch of instrumentation that you want to take to Mars, including instrumentation that may tell you whether they're complex molecules. One thing I wanted to mention, and I forgot to add to my talk, and that is that survival of complex organic molecules may well have been assisted by the catalytic effect of clays here on Earth, and may well have happened on Mars as well. Clays offer very interesting structures, as I've written in a GSA paper, that can help organize complex organic molecules. And it also gives an option for their preservation, at least as molecular structures during this period of very large impact activity that Dave has described.
Okay.
Thank you very
That's
much.
Great. Thank you so much for that.